Ball is thrown off the top of a cliff with initial velocity of 4 meters per second upwards with a horizontal velocity of 6 meters per second. Neglect air resistance. Vertically, the ball experiences acceleration due to gravity, which we're always going to have on our problems. And horizontally, the ball is moving at a constant velocity. Again, we're always going to have that on our problems. What is the direction and the speed of the ball after 4 seconds? So, as was previously described in the text, define the speed and the direction of the ball after the time period, or after a distance even. You've got to find the velocity horizontally and vertically, and then you're going to create a triangle. And from that triangle, you're going to use trig and geometry to calculate the direction and the magnitude. So, let's start with the problem. First thing to look at is our table of givens. Remember, when doing projectile motion, to organize your work, put it in some kind of table. And so this one has the variables vox TVA, VOX TVA, and I'm looking for the vertical velocity in the VY and the VX velocity. Now, remember too, for our rule, every time we have an acceleration, we have a list of givens. So I have two accelerations, one vertical and one horizontal. So that means I have two lists of givens. So here are the values. Vertically, I know the initial velocity is 4 meters per second and it's going upwards, so that'll be positive in our formulas. Time is 4 seconds. Acceleration is negative, or 9.8 meters per second squared going down, which will make it negative. Horizontally, I've got 6 meters per second, 4 seconds, and 0. What I also have horizontally is the fact that this velocity of Vx naught is the same as this velocity Vx naught. So I already know that, that's because the acceleration down here is 0, which means there's no change in the velocity. That's what that number tells us. Alright, so let's continue on with some of these hints. Get a little more room. Now, to find the velocity, I'm going to use the vertical givens to find the velocity. So that's here, using only the vertical columns of givens up here. Don't cross over to the horizontal. Vertical answer, vertical givens. So v in the y direction is equal to v naught plus at from the vertical list. So 4 is going up, that's positive. Acceleration is downward, so that's negative, times 4 seconds. And that gives me a negative 32 meters per second. So that means it's going downwards because my final answer there is negative. I'm going to scroll down the page a little bit. Now, if I look at the other variables over here, these are the horizontal variables right there. And again, I'm only using the variables in the horizontal column. Don't grab them from the other column. And when I use this, acceleration is equal to 0, so that tells me that the final velocity is equal to 6. Because acceleration is a change in velocity, there's no change. So that's easy enough to figure out. Alright, at this point I got the horizontal and I've got the vertical velocity. Now let's continue on. So what I'm going to do is I'm going to make another triangle. I had one triangle to start off the problem on a lot of these projectile motion problems, but this is going to be the triangle at the end. And what I have is I have a downward velocity, and it's down because it's negative up here. And horizontally, I've got the bottom piece of the triangle going to the right. So here's the vertical, and here's the horizontal going to the right. And that's because of the signs. Alright, so now I've got my triangle drawn. Kind of generically, it's not scaled by any means. Next thing I'm going to do is I'm going to use trig and geometry to figure out the angle theta and the magnitude. That's the length of the red arrow. So I'm going to use the trig to find out the angle. That's going to be right here. So there's my trig to get 80.3 degrees with the ground. And then I'm going to use Pythagorean's theorem, a squared plus b squared equals c squared, to figure out how long that red line is. So a squared plus b squared equals c squared. Notice on that problem, I dropped the negative signs. Once I drew my triangle, I didn't need my negative sign on the vertical velocity anymore.